right, let's go ahead and start. This is just the first of, well, I won't say the first of many, because who knows, with all these brilliant people here, we might solve all the problems and come up with all the designs. But what I'm trying to do is gather as broad input as possible, because this has to do with the spec for M17 and our uplink and the stuff that we need, I think, for a higher bitrate microwave link. If I'm assuming that we would like to see that happen, that we don't want to just use the 9600 bit per second mode that's in the specification. So I'm trying my best to get all of the assumptions out of the way. So I'm going to put the link to the spec in chat so that we all have what I'm looking at. I believe this is the latest and greatest. There's been some formatting changes and some location changes, but this I believe is the correct one. And let's see if I can also put in a picture. Yes, I'll put in a photo that I just took, and it's the only thing that really mentions IPv4 in the spec. And yeah, here we go. It's in the, there we go. Yeah. It's called a data type specifier. And the specification, I think it's in the application section, but if you go to the spec and then search for IPv4, you can find it right away. But I put a screenshot of it, and that's it. That's the only place where IPv4 is mentioned. So why are we bringing this up? Well, because there's 3 different use cases that I can think of for M17. And one is what you have in the spec and what is generally assumed to be M17 right now, and that is 9600 bits per second voice for VHF, UHF. And it assumes Codec 2 and has a fairly large amount of overhead by my way of thinking. But I think most of that is normal stuff that's in other similar protocols. So that's one use case, is voice, digital voice, VHF, UHF. And there's an awful lot of time and attention being plowed into it, and a lot of interesting circuits and implementations, and things are going pretty well. Then the other use case, it's the idea of a 9600 bits per second data or packet mode. And ever so often in the past 6 months to a year, packet or data mode has popped up in M17 project. There used to be a PDF that was supposed to be the packet spec, and it was a parallel document to the spec I just linked. That seems to have disappeared. And so there isn't really current data or packet mode. There are 2 different modes in M17. There's a streaming, so that you don't know how many packets or frames you're going to get, and then the case where it is packetized, or it's kind of called packet mode. In both cases, though, that seems to be voice. They're assuming voice. And the third use case is a higher bitrate mode for microwave, which is kind of where we're at. So since microwave allows us to have such much wider bandwidths, and since our baseline for FDMA uplink assumes up to 100 kilohertz, that's what we have right now as an assumption. You get about 100 kilohertz and 96 kilohertz, and we expect your signal to be somewhere around 25 kilohertz wide. Now that's been our baseline assumption for a long time. Those are numbers that space people say are okay. You know, they could change. That's why we're trying to get things to work over the air as quickly as possible, because these are the sorts of things that you will find out very quickly do or do not work. But in any case, it doesn't matter what the end number of uplink channels are. We are definitely can afford to have a much higher bit rate. If all we did was increase the bit rate to make it to where it wasn't a 3200 bit per second codec, then that would be a big step forward. There's no limitation on the bit rate for us at microwave, or no reasonable limitation. So those are the 3 different use cases, and then there's a question of, okay, so since we're data centric and we want to be able to ship data, and since we have we do not have the same protocol all the way through, that we have the opportunity to use DVB-S2, S2X on the downlink, and we have M17 may be one of many different things that's transmitted on the uplink that we simply digitize and then package that stuff up for people in channels. The advantage of having a native uplink like M17 is that you get more traction and more leverage. If you have one that, okay, if you use this, then it unlocks lots of different features. We think that might be a positive force for good. So the data type specifiers include IPv4, which is what we're kind of focusing on, but the other ones are raw, AX.25, APRS, 6LoWPAN, IPv4, SMS, and Winlink. So since these protocol types are in there, it kind of begs the question of, well, what do we need to add to the spec, if anything, in order to take advantage of this? And what might we want to do at microwave to handle IP over M17? And that was a question that was raised this past week by Ron Economos on Slack. And it's also a question that he raised a while back in 2021. So I'm going to read it to you. He says, what needs to be defined is how to do IP over M17. In the spec, there's a protocol identifier for IPv4, and that's it. And before, a year ago, he said, I guess M17 supports IPv4, but I'm not exactly sure how. And the spec seems pretty vague on that. Okay, so that's what was said by Ron. I'm going to go ahead and put all of this into the chat. So what I've done is I've gone back into Slack and found all the comments from Howie DeFelice in response to Ron's initial question, and then another set of comments from Anshul. And I'm hoping that it works. And it looks like it's too big. Okay, so I'm going to do chunks. Because I think that would be a little bit better than me reading words to you. There we go. Okay. So he agreed that it was vague, by the way. He's starting off by agreeing with Ron. And Howie's take was that we don't do anything with IPv4. We don't mess with M17. That we use native M17 on the uplink, and that's it. And then we'd end up putting the M17 frames into GSE data fields, the generic stream encapsulation on DVB S2 downlink.
Do we have a block diagram, a working block diagram that we're proposing or anything?
A block diagram of M17?
No, of like the entire system, like
yes,
like the use model.
Use model. Yeah, we have an architectural diagram and a functional diagram.
Yeah,
I don't know if that would that help?
Well, I was just, that I think that's what I was thinking about. As far as help is like for the naive, like let's say, like me, I would have a idea where it more or less fits in a picture's worth.
Okay, yeah. Probably the most important thing to know is that we have a frequency division multiple access uplink on 5 gigahertz. And so those frequency division channels would be, some of them, maybe all of them, would be full of M17 signals. And then in our transponder, what we do is we take in all those channels, they're digitized, and then they're packed into DVB S2 or S2X frames. And then there's some quality of service stuff, there's some adaptive coding and modulation stuff. But it is a digitally multiplexing transponder. So it goes from 5 gigahertz and it transmits at 10 gigahertz. The protocols on the uplink and the protocols on the downlink are different. So we have an opportunity to really screw things up, you know, and make it overly complicated and you know, lots and lots of overhead. It's packets all the way down. It's all headers, you know. We could easily do something like that. You know, so does that help a little bit, or do you want me to go fetch the architecture document?
No, just a link would be good. I could, you know, I think if we just if you have one, then a link. If
Yes.
you don't, then
Yeah, it's in the
then
it's in the repo, and I'll go get it for you. I'm gonna paste in the rest of the comments. That's the second comment is also from Howie, and then this last one is what I thought we had decided, what Anshul decided in 2021 in the conversation back then.
so Anshul saying that we don't need IP as an intermediate step, right?
Yeah.
So that would mean developing an M17 interface that uses what, raw?
Gosh, that's a really good question. I don't know. It would, and that's the sort of question that we should, that's exactly right to ask. It's so now it's like, okay, well, we're just going to handle native M17. We're not trying to put M17 into IP packets, you know, which we don't need to do. We don't have to do that. We can actually, since it's packetized, it's essentially already frames of data that can go right into GSE on the downlink. At least that's my opinion, my understanding of what we're capable of doing with GSE. So M17 would have as its payload whatever it had. Right now, the only the implementations are focused on voice, codec to voice. So we would recognize it as M17 somehow, and then load those frames up as a generic stream. Use it as GSE. That'd be the transport stream. So that was kind of my, you know, crude kind of mental model of how to handle it. But there's an awful lot more that I think can be done. And the question keeps coming up of data. If you were going to ship data through M17 protocol, is there something else that needs to be done? It certainly does not seem to be very efficient at 9600 bits per second to then say that your payload is going to be IPv4. So I'm curious. I guess I have lots of questions. I probably have more questions than answers. You know, I see these protocol types, and I'm like, what exactly are we expected to do with them? And if we wanted data to come through an uplink using M17, then what do we do? So I'll turn it over to you all for more questions or to attempt to answer any of mine, you know, where I'm wrong would be good to know.
On the system, like let's say we're trying to kind of design to, have we looked and compared it to like CCSDS and I mean, that's kind of a very popular open source system that a lot of people are using and being adopted. So what is the advantage of using this, you know, what we're trying to do over something else?
I think it's probably both and not either or. By choosing M17 as the native uplink, we're helping a really cool open source project that's from amateur radio and for amateur radio. So that's one reason, and it does not exclude using anything from CCSDS. Paul may know more about that, or Jay or Douglas might have a different take on it.
Well, I don't know anything about CCSDS, so I can't help with that.
Yeah, it's just open source set of specs that kind of define, you know, the different layers of the communication, whatever. You know, there's framing, there's, you know, the transport, the packets and all that.
I'm familiar with like CCSDS privileges and emphasizes LDBC, which is what we use for DBBS2. And I know that there's a really good document from CCSDS on how to implement DVBS2 within CCSDS links in a compatible way. That you have to do a little bit of work, but it's almost there. So I've never thought about this question with respect to the uplink. I've always looked at our compatibility with CCSDS on the downlink. So I think maybe we can go look, but like I said, we're not. It's we want to make sure that we are compatible with and fully utilize M17, and now's the time to change the specification, or if necessary. So I don't want to give off the vibe that I believe that it's that we have to change it. We may look at this and walk through these questions and say that we don't need to change anything. But I'd like to fully utilize and make M17 as perfect as possible for what we want to use, but it's not the only uplink protocol that we'll be seeing, or that we can accept. Whatever shows up in the channel, that's going to get digitized and put into frames for you to hear on the other side. So it can be all sorts of things.
I believe that digitizing what comes on the uplink is an exception rather than a rule. That the normal case would be that it would be demodulated, and the demodulated data would go into some kind of a multiplex downlink.
Yeah, you're correct. Sorry about that. That was inaccurate.
I think if we do want to run data through M17 using M17 as much as possible of the standard existing M17 protocol on the uplink, then I think it's pretty clear how you put data in there. I mean, there's a type ID, and maybe that's all you need. It's pretty clear that they intend for you to put packets of whatever you're transmitting into packets of M17, and that's all you need to know about that as far as I can see. Now, there are some consequences. One consequence is that the M17 packet has a limited size, which is smaller than the typical size limit on, say, an Ethernet. But IP knows how to deal with that. It just means you have to fragment, may have to fragment IP packets to fit them into M17 packets. That means the adaptation layer may be a little more complicated than you'd like, but I think you'd need that no matter what your packet size limit was, unless it was 65,535, which is the actual limit on IP packets.
Yeah, because I believe the packet size M17, unless I'm misunderstanding it, the packet size is driven by voice. So you can't have very long frames, long packets, and still have fairly low latency voice.
Well, the packet format in M17 is not the same as the voice frame the voice frame limit.
Okay.
There's a finite number of voice frames that you can stack up to make a data frame.
Okay.
And the reason it's limited is because they want to encode the length in a certain way. That I'm not sure that's a great reason to have it limited, but there it is. So you can get up to much longer than a voice frame.
Okay.
I don't know exactly what it translates into in time units, but it's like a second or more, just offhand, of data, not constrained by voice latency.
Okay. All right. So the other that kind of brings back to, let's see, Ron asked what needs to be defined as how to do IP over M17, and it doesn't really sound like any much more has to be done to do IP in M17. But I've also seen it asked the other way around, M17 over IP. Does that make any sense? And is that something that we need to talk about?
Is that what they're already doing to talk to reflectors and stuff?
I think so.
Yes, I believe it is. And that's actually pretty well defined in the spec already. It's just in one of the appendices.
Okay.
There's an appendix on IP networking that includes exactly how you put an M17 packet into, and its auxiliary control stuff as well, into IP. But it's oriented strictly toward what Jay said, the linking repeaters. It may be good enough. We'd have to look at it carefully and make sure that everything we need is in there. But depends on what the use case is. Why are we putting
Yeah.
M17 into IP?
Yeah.
we're-
I don't think we need to. I mean, unless we're going to set up reflectors, and unless we want to, then and unless that is what we want to use in a pure way, but that would be duplicating the reflector network. So
it
I
might
mean,
it might be useful for the spacecraft or terrestrial phase 4 thing to be compatible with the reflector network. So just plug in.
Yeah. Which immediately raises the reason why QO100 is not accessible over a terrestrial network, because they were very concerned about it getting completely flooded by essentially VoIP or IP voice users. And that was a call made very, very early on to force people to access this particular spacecraft over the air, and you had to be in the footprint. No remote stations, or very limited remote stations just for demos, and no echo link into into the QO100. So we would have to then make the same sort of choice for terrestrial. I can see where mountaintop terrestrial, essentially a ground sat in Los Angeles would end up just being another node in M17. And I would expect a similar sort of situation that we have at SBMS meetings, where there's 50 people on Zoom and there's 15 people in the room at the in-person meeting, and there's 1 or 2 people on ATV checking into the meeting, and it's the same 2 people every month. And that if we wanted to encourage stations, I'm pretty sure this is the same reasoning from AMSAT DL. You want to encourage people to actually build hardware that will actually talk with a mountaintop system or a network like ATN or a QO100, then you can't connect up to the equivalent of Zoom. So I don't think we have to decide that right now, but to me, it's something that we'd want to do. I'd lean more towards going ahead and putting that in there because of the potential usefulness and the number of people that would then be available to use it. So I don't know. What do y'all think?
So you're saying that you'd have M17 coming in, and then you would then take the M17 and packetize it or do it over IP. So then you could potentially have one IP pipe going from the hardware to somewhere, whether it's to other reflectors or you're using IP as your sole downlink or piece of your downlink, instead of bringing all the different M17 channels up and all the M17 channels just sort of existing back down. You take all the M17 channels in and then pipe them all out through IP. I'm not sure I'm following. That's why I'm asking.
I don't think we're proposing to use the satellite as the backbone for the repeater linking. We're proposing to participate in the repeater linking as a repeater, basically. So if anybody using the satellite wanted to get involved in that, they could do whatever the appropriate command sequences are. I don't know how that even works on M17. I'm not sure they do yet. And link to another site, which may or may not be part of the terrestrial network.
Yeah, it's a fork, so you'd have I guess the most sensible answer to your question is yes. It's if we added a compatibility with the linked repeater system, it would be it'd be M17 coming in, and then it would be put over IP using what's in this appendix. And there's all sorts of repercussions for these sorts of decisions, but it's not either or, it's both. You're adding.
Could be. And that might be good for, like you're saying, the mountaintops, not necessarily the satellites, but maybe it's more applicable to the mountaintop application.
I can see where it would be, for sure, that you would then, yes, it would
Good.
be.
I think that's an excellent point, and that leads us to a conclusion that that we're wrapping M17 in their IP networking framework that's defined in this appendix is outside the air interface and probably not done inside of the phase 4 transponder. It would be a separate adaptation layer that you'd add to a mountaintop thing if you wanted to do that with your mountaintop.
Yeah, I concur.
Okay, that's helpful, I think.
Yeah, it is. I am warming up to this idea, and it's something that we could conceivably prototype with the multimedia beacon as it, gets stronger and bigger and more real. That's something that seems to be more appropriate for the ground.
So you're saying it's not actually part of the transponder project, but it could be it could be a processing piece that interfaces to the in and out of the transponder.
Yes.
So on the input side, it could be getting fed also to M17, and the output side, it just sticks out IP. And that's a separate block. That's not like part of the transponder project. That's just a block of function.
Yeah, I think that's well said.
Yeah, it would be a feature of or a version of the ground station. The transponder itself would be innocent of any such information, I think.
So you're not going to try to do that in the satellite. You would do that aggregation on a ground station, and maybe send IP up and down. Have an IP stream that was on the ground already, channel a bunch of M17 aggregated into an IP stream up and back down.
Yeah,
or you could have a bunch of M17 going up, but at that point it's still going to be M17 coming back down.
Yeah, it sounds very similar to the ARAP, the amateur radio access point, which is a thing. It's a concept that where you have HTs and analog, or P25 or whatever, and that whatever footprint you can pick up within an area of mobile communications like that, VHF, UHF, that it's aggregated and sent up in a channel, and that is an uplink, and then all of a sudden your area, which may be a communications emergency or an event of some sort, all of a sudden that has a footprint as wide as whatever satellite we're working through. So it's a similar concept, I think, to that, and it's that is definitely outside of the transponder. It's just another channel. It might have to be a bigger channel than what we are assuming, and we've talked about channel bonding, and I know a little bit about that. So it would be, it's like, okay, well, we asked ourselves, well, how big is the entire 2-meter band? Why not just say that we'll put the entire 2-meter band in a particular area on the up and down, if you needed to, and this was back when we were speaking actively with FEMA. This was something that they were like, you can do that. And I'm like, well, yeah, that's it's an implementation challenge. It's not a blank paper design problem. These are things that we know how to do. It would take some fairly high horsepower stuff for budgets like us, but the Motorola has a radio that does this. I mean, they do exist. So to me, that it sort of sounds like the same concept. And again, it doesn't require us to change our interface or add any workload to the transponder brains.
Yeah, I think if you ever wanted to aggregate and then use that spacecraft as a backhaul, that's just data.
Yeah.
The spacecraft doesn't need to know anything about that.
Yeah,
it's an important use case for why we need data that's broader band than M17 though. So we could possibly aggregate multiple M17s if need be and handle it as a data stream.
Let's talk about
But there are
that.
lots of other use cases for that, like video.
Yeah, I'd like to talk about that because there's always going to be a big pressure to just use whatever, to use M17, use the 9600 bit per second, because it's going to be a tough uphill battle to get people to develop, build, buy, manufacture, adopt radios that do yet another digital voice protocol. This is a huge effort. I think it's going to be successful. I wouldn't spend a lot of time on it if I didn't, but I know it's a really very hard thing. So, and then what are we going to do? Turn right around and say, you have to have a broader band radio to do M17 over the satellite. So in terms of like market awareness, market acceptance, product success, protocol success, I think we have to look really, really hard at, we have to support the 9600 bit version. But wow, is it so harshly limited in terms of bits per second? So
So let me
what do we do?
poke at it. Let me poke at that assumption before we go on to that problem. You're assuming that a user would have a off-the-shelf M17, maybe even an HT, but an M17 radio of some sort, and he'd want to be able to use that on the satellite. And it can't, right? Because it's the wrong band and the wrong power and the wrong gain and everything. So at minimum, he's going to have like an up converter.
Yes.
And then the down converter is going to be even more complicated. It's actually a DVB-S2 receiver and lots of other stuff. So does it make sense to even worry about that HT? I mean, maybe it's a ground station that happens to be compatible with M17 and not an M17 radio you drop into a ground station.
Yeah, I mean, it's at 5 and 10 gigahertz. It's not VHF, UHF. That's true. It's just I'm anticipating objections and anticipating expectations and trying to find any traction that will help us.
Well, if we're not transmitting M17 on the downlink, then that radio that they bought is not going to be helpful by itself, even if it had transverters on it.
Right, that's
Or,
true.
a split band transverter.
Yeah. Okay. So yeah,
I think that maybe people are going to say that, of course. Why can't I use my HT? They've said that on about their FM HTs for every single sideband satellite there's been, and so on and so on. At some point, you just have to say, yeah, okay, it's going to take some new equipment.
Okay, then the next question is, how do we take the M17 spec and make it higher bit per second? What do we need to change? What exactly is going to break if we really open this up? What's the right number? What are the limits? What's the choke points? Every protocol has them. Where do we run out of gas? What do we need to poke at? And I know we can't, unless you all are way better at protocol in the head than I am. I mean, I have to actually like write Python scripts and have spreadsheets to figure this stuff out, right? Okay, so I'm not expecting answers to that question, but I think we need to start working on an M17 uplink spec for 5 gigahertz for what we're doing. And we're going to have to start transmitting it over the air, or at least conduct it into our circuits and start working with it. Like, well, Douglas is here. He probably can bite into this and probably have it working in GNU radio before breakfast. I don't know, but like I think that's what we need to dig into, is how do we take this spec and make a broader band with higher bit rate, really is what I'm after.
So, I've been working on trying to help them sort out the spec, because whereas the PHY and data link and stuff, it's very mishmash right now. When you look at it, you can't really break out the PHY from the data link easily. So I've been trying to do some rewrites. They're not in the spec yet. They're on my own repo. We've been hashing them out. But I think that with the PHY getting defined very carefully with the VHF UHF aspect piece, And then if the data link stuff is moved out of the PHY that's it's in there now, it might be a clean break to be able to swap in a new PHY at a higher data rate. But
Right.
we do need to go back and look to see, is there something inherent in that data link, data transport piece that breaks, like you're saying? Like, does it rely inherently on, the bit rate to do with the codec, which it kind of does. So how do you deal with that?
Right. And that when I talk up M17 to groups and people, I always emphasize that it's a layered protocol. And to me, like from the start, it was the intention and the execution are, yeah, it's layered, but it isn't quite, it isn't as modular in this spec as it probably should be. So we're not there yet. And I deeply appreciate the work that you're doing to make that actual, to make what I'm promising people actually true.
I think it's because I heard you promising people that made me look at it. I go,
Oh,
oh
dear.
man.
Yeah, it's supposed to be. And when I ask questions, good things usually happen, when I ask them, and then ever so often they get blank looks. So just like with us, we act the same way. So I'm very optimistic. I think that this protocol can be saved. It's like that column from Family Circus magazine. Can this protocol be saved? Some of them cannot. Some of them are just terrible. And so one of them starts with the letter A and is very frustrating to work with. But this one, no, I think we can achieve it. We can get there. So I guess it sounds like the two jobs, you're excellent and very appreciated work, which will change the future of ham radio for everyone. It will. You're like messing with the actual DNA. Like, so it sounds like those are intertwined problems. Like I guess what I'm most frightened of, if I'm not really frightened of anything, but like I'm most kind of like looking at is, is there anything broken? I think, which is what you said. Like, is there anything that's going to prevent us from doing what we want? And now is the time to change that, as long as it doesn't break VHF, UHF voice. Like I don't want to put anything in there that would help us later if it's going to wreck which I can't think. I'm not saying that would happen, or I don't know the details, but I'm just, my instincts and design patterns and head, so anything we propose can only help them, or should only help them, and if it helps us, and we should accept whatever works for VHF, UHF, and then when we're looking at expanding to the bit rate.
There are a lot of assumptions based on the codec speed.
Yes.
And
then I asked the question, it was months ago now, but I kind of had a tantrum about the quality of the codec, because it was on the Friday net. It just sounds like shit. And but that's all codecs that are like ambi codecs, all the ambi codecs sound like crap, and I'm expecting codec 2 to be better. And I'm hearing person after person sound worse than JSU System Fusion. And I was like, we cannot have this be the product that we're trying to sell. We can't. And that sparked some work on the 3200 bit per second codec from Wojciech. And I think that there's some improvements that can be found from his work. And then we seriously looked at how hard is it to just drop in a new codec, to drop in Opus or Luna, or there's a number of them. And even if you just limit yourself to open source, you still have two big ones, Opus and Codec 2. But at 3200 bits per second, it still doesn't sound good to me. And with everything, it turns out that with everything being kind of assuming Codec 2, there's an awful lot of stuff that seems like it's hanging on that decision. So in the end, they were like, oh, we're just going to stay with Codec 2, which is fine as long as it does not sound like it sounded months ago. It just has to get better. And that, but that's a long-term sort of position that I have, is that all of this work to make all of these beautiful radios, from all these companies, and then you take it out of the box and you go to talk to your friends and you can't recognize who they are. and it just, it works, it hurts me. So I don't want us to have that problem. And I don't want M17 VHF UHF to have that problem, to at least mitigate it as much as possible. But at 9600 bits per second, what can you do? Can you get any faster codec crammed in there? You know, what else do you have to give up? Because, you know, that's that's it's not a lot of bits really.
Yeah,
And
everything about M17 is designed around two constraints. The data rate of the codec, which highest they're considering is 3200, and the assumption that they're going to have to cram into the existing terrestrial channel plan. And that's not a great combination because there's not much left in the way of elbow room when you try to cram into the channel plan, especially if you try to be compatible with the more narrowband channel plan that people seem to think is the future. These are not problems that we have on this project, and it's okay to transport M17 at, you know, in that 3200 bit per second throughput mode as a compatibility option.
yeah, if you want
But
to
is that
hear
really
that,
the best way to run voice over a P4
no,
transponder? No,
I
probably not.
I will veto that. Well,
So we need to be thinking about,
lowercase v. I'll veto that. I really don't want us to do that. I want it to sound absolutely gorgeous.
so either we're going to have to convince M17 that they need better bit rates on their vocoders, or we're going to have to implement a P4 voice mode that's not M17 or M17 plus plus or something like that.
Where would we put a P4? Where would we put that? Is there any place in the, is there any good place in the protocol to just ask them to just go ahead and put that in? Because that one change might be enough to then give us the freedom to have it be completely different. Just
Not
like
sure what
the,
you're asking. Are you asking it for a bit field that then tells them that it's a higher bit, that like everything's different?
yes.
Hmm.
Is there a reasonable place to put like, okay, now you're going to switch to this, to to a microwave protocol. Now you're going to use a proper codec. Like where is the codec declared anywhere? I think it is.
In the spec, you're saying?
Yeah. Isn't there a field?
Why don't we, okay, I have the spec that you have. I went to that link. Can I share the screen and just show that, and then we can navigate
Oh.
the document?
Oh yeah, that's a good idea. Let me make sure. Yes, pardon me,
Okay,
you should be able to do that right now.
all right, so let's see here, screen 2, share. Okay, there it is. And then just, if you guys are familiar with the spec, just tell me where to go. These are the main pieces. I mean, from what I see here, this is kind of right after the overview. You
Yeah.
have sets of 2 bits coming in. You got this upsampler, the filter, and then frequency modulation to 4 FSK. You know, so this is, I think what you're talking about is like this all-in-one, nothing separated out from whatever, right? And then if we, you know, they kind of define that there. Some fields there, obviously. Don't really break down these block diagrams, and so you have these kind of small sections
Yeah,
on the
where's the
F-
where's the codec assumed? Where's the first place where we hit any discussion of the codec?
So one thing, yeah, I know, that's what I'm wondering. So one thing I'd like to see is
The
these
data
kind
link.
of these, yeah, I'll go there in a second. These block diagrams are not broken down into these
Yeah.
paragraphs here, like where does a preamble, you know?
Yeah,
this-
that's going to be improved soon.
Okay, so let's go to the data link layer. In the data link layer, hold up.
Yeah, so go down. Yeah, it doesn't really say which vocode. There's some rates there. There's not a lot of free bits kicking around. So
No,
if you go
there's
back,
not.
if you
I
go
mean,
back up
and if
a
there
little bit,
was, then it would then that would be maybe a point of criticism. There was just unused bits are laying around that we had yet to inconvenience. That would
and there's
Well, there's a massive number of bits in the full length setup field, right? That there's 112 bits of metadata that can be used for anything.
In here,
There's room for
yeah.
stuff in the type field. There's some unused bits in someplace else.
Yeah, if you go up a bit and look at the keep going a little bit further, a little more right there. So that's what Paul's saying is in the link setup frame, the setup frame is the meta field, and then those meta, I don't remember, do those metas get broken up and eventually get resent with the broken up, was it the lich?
well, there's lots of bits
Yeah.
here in this LSF field, right? 48 bits and 48 bits for source and destination. That's a big number. Type bits, 16 bits. So you got a lot of different ones there, and the meta as well, 112 bits. So I would be surprised if we couldn't figure something out. I mean, is that your take?
yeah, that's yeah, I think so. I mean, the sort of the goal would be, okay, so we have this spec, and then can we get a hook in to where a receiver that then knew what was coming could, which is our radios, would know what to do. And then I'm thinking that would help. I guess the other way to do this is to just leave this completely alone and do a totally separate parallel effort that's essentially starts over from scratch following the same type of.
So well, we don't know what they're doing with this, right? I mean, is this, where's the definition of the type field and the meta field? So we
Type
have no
is,
idea.
type is
It's
right
right after.
below.
Huh?
Go down an inch, just the field of type field.
Oh, okay.
Oh,
So
yeah.
Okay.
You could grab something in 11 through 15 then.
Yeah.
Oh, I see. Okay, yeah.
I couldn't find anything about what the channel access number is supposed to be about. Jay, do you know what that is?
I haven't dug deep enough into this layer yet. I'm having enough trouble with the phi layer. So,
Okay.
but I'm almost there.
What
Okay.
kind of issues are you having with the file layer? Because
There's not really issues. It's more just making sure things are well defined and clear. Some of the wording is in this version. Some of the wording is a little bit tough. There's references to items that really should only be in the data link layer. Like when I start talking about what type of sync burst words, so it's like you shouldn't be talking about what type of sync burst words. You should just be saying there's a sync burst and this is what it is. So that's a lot of it's just detangling the layers a little bit.
Yeah.
The only point contention that I've run into so far, and it's not that big of a deal, but at this level, the data is XORed with random data, so you get a somewhat randomized bit stream, so that you can at least guarantee that you're getting 0 and 1 transitions, and the data is just a table of random numbers, and it wasn't generated by any specific algorithm. So anybody that implements it actually has to put the table in their system.
So kind of a call out a spec for a scrambler is what you're saying?
Yeah, go all the way down. If you go all the way to the end of this section, right? Okay, and then the last paragraph. Yep.
Yeah. So I mean, like here, instead of just saying something generic like that, we could call out a specific scrambler. I mean, that's what the goal is, right?
Right, you could, but there's resistance to do it now because there's already been implementations using the table of 46 random bytes that are in the appendix.
Oh, I see, okay.
So I understand why, and to a certain extent, the argument was, well, are 6 bytes going to kill you? Probably not, unless you're really constrained in an FPGA or something, and you'd just rather do it that way. But anyway, that's the type of problems that are popping up where it's not like even the algorithm here isn't very clear. I mean, you can do lots of different ways of doing an XOR to generate a scrambler. So I had to go into the code, and I'm looking at the code now and how they're doing it, and I'm going to make sure that that's in here so that people understand it.
Thank you.
Yeah,
That's good work.
what's that? I mean, the one thing that would be nice, I think, like if you're gonna ask for anything is potentially, I don't know. In some cases, I like more. I don't always like more, but I mean more. Like you said, you kind of said this right at the beginning, where 9 kilohertz channel, that can be, tight. And I'm not necessarily a big fan of 4FSK from a frequency modulation standpoint. And this is a digital system. Can't we select a more modern alternative to the, modulation even?
Yeah, the modulation for us on the uplink is 4-area minimum frequency shift keying. So similar. And that made all the RF people happy. But
Say that again.
minimum frequency shift keying. So 4-area MFSK is our baseline modulation on the uplink.
Yeah, so you can make MSK look like certainly FS, like a FSK, and you could make it, in a digital implementation, make it look like 4FSK. I don't really think that's the best from a bandwidth standpoint, though.
It's good because of the envelope. It made the RF people happy. So they were, and that's making people happy, for the right reasons is.
And MSK is a constant envelope.
Yes.
Modulation scheme. Yeah.
Yeah. It isn't the fanciest, and that's the baseline.
Anyways, I don't know anything else other than that. That's my
No, I think, yeah, I think this is a lot of good work, and I think that I think we have some answers and some more questions and some questions for them. It'd be interesting to know what the channel access number is. It says it's I recall something about. Does this come from DMR? Is this a DMR thing? It sounds familiar. It may just be using the same. This may not be implemented, or there may have been some idea, but it's vaguely familiar to me. But I'll go ahead. I'm going to go ahead and ask them if we can possibly get something in the type field. I'm hoping that will make our job easier, that we can then work on implementing a much higher bit rate version that would then be triggered by that particular type field. Does it sound like something that we should ask for, knowing all the things we don't know right now?
We probably have to figure out a way to negotiate the rate, right, in the link, like when you start listening. Yeah,
and we can,
just,
since it's in order to acquire, there's a loop. So you have to show up in the, you have to be able to show up in order to get access to to the transponder. So there is some loop going on there. That's a good point about negotiating.
So would you do something like you'd have this field in the link setup frame and you'd start off at 9600 with the first link setup and then switch, but
Oh,
that doesn't help you with the other, the break, because you only get the link setup frame when you first start transmitting. After that, it's all broken up in made up in the super frame. So you've got the 1/6 of each link setup frame per frame. Yeah, there you go.
You get it. You just have to wait 6 frames to get it. You don't get
You
it all
get-
at once.
Right, but if you changed rates, like say you were looking at the bit field to tell some on the first link setup, so that you're going to change rates so that the receiver knew that it was going to be a fast M17 as opposed to regular. Once it's fast M17, you can't jump back. You can't jump in. Well, I suppose you could. If your receiver's smart enough, I suppose you can jump back and forth. So
ooh,
If your
Yeah,
receiver is
I
that
think
smart,
that's a good point. I think
If you're-
you're bringing up a really good point, Jay.
if your receiver is that smart, you don't need any help from the header bits though.
right.
Just look at the modulation and say, oh, this is fast M17. I'm going to use that. I'm
Yeah.
going to use a whole different set of definitions.
So we don't care. So the fast versus slow M17, we don't need the type bit for, but maybe for different codecs, we do, since it doesn't look like there's a way to offer different codecs.
right.
Yeah, that's a different issue.
That is a
Different
different
3200 bit per second or 1600 bit per second codecs either have to be self-identifying or we need some fields that don't exist yet.
Well, there was fields for 1600 versus 3200 rates. There are fields for that.
Yeah, they've followed
Yeah.
it's sort of like the Yaesu system fusion model where you get the highest bit rate is all the bits, and then you also get these half the bits and use the other half for data.
Yeah.
Where are those bits you're talking about?
Right there. Your voice coder rates.
It's bit 1 and 2 in the type field.
Yeah, okay.
If it's voice, in other words, that the bits are 1 and 0, then you get all the bits for voice. And if the bits are 1 and 1, then you get half the bits for voice.
But that
It's
doesn't
very
actually
coarse.
say codec 2. It just
Right.
says 3200 bits per second.
Correct. In fact,
Mm-hmm.
I searched for codec 2 in the search documentation and it came up 0 for me.
Yeah, it's not in there. And nor should it be. I mean, there should be
Right.
codec is an application layer thing or
Yeah.
beyond.
I mean, if it was, I would not put the voice codec rates in the data link layer at all, but I'm pretty extreme on this issue that the negotiation of the codec needs to be at the application layer. And if you want to sound like Ambi or you want people to sound like Ambi, you can choose that. But the rest of us would like to recognize our friends.
Well, you do have to design in your maximum bit per second.
Yeah, that's true. And that's one of the questions that I scribbled down here on my notebook.
So
Sorry.
go ahead, Paul. Sorry.
I was just going to say that pushing that up above 3200 bits per second is a complete redesign. There's nothing left of M17 once you've done that. You could try to handle it as a packet, but that's going to have latency problems. I mean, you can get up to like 55,000 bits per second or something like that throughput on data, but only with maximum length packets.
There is a way around this, and that is to design an M17 9600, or narrow, or I don't know what we would call it. This is just in M17. So take M17 and then have it be a voice memo instead of live real-time voice. That way you can build up your 32K codec frames in the application layer, and then hear the voice memo, similar to WhatsApp or any number of other things that let you record and then send. And with a long
Mm.
latency link like a geo, that's how you get around something like this if you had to. So if there's no way to put in to drop in a much higher rate codec, even with a lot higher bit rate without ripping it up, then well, I'll be somewhat disappointed, but I wouldn't be too surprised. But the voice memo approach is the way that you kind of get around the limitations of your codec.
Yeah, that's a good point, and that raises a bunch of interesting consequences. At that point, it becomes basically a data service,
Yes.
and you may still want to define things like what's your chunking size, just to get the best behavior possible out of it. I mean, on a geostationary satellite, you're consigned to pseudo real time at best anyway. You're not really going to have a conversation unless you have trained speakers, and even then it can be quite distracting.
Yep.
So a little bit of delay won't hurt, but a lot of delay will change how it feels.
Okay. Any last comments before we close? And we will meet again. You look like you're
Another
thinking
thing,
really,
we're
really
gonna-
hard, Paul.
Yeah, I didn't seem like we were done yet, but I'm not
Oh,
sure what
well,
else to talk about.
Well, I didn't want to overcommit people since I proposed an hour, and we've filled it up with lots of good questions and answers. So I wanted to be respectful of folks' time and go ahead and close it. And then we will meet again to talk about this stuff. It sounds like there's a lot of work that's going on. We've raised a lot of questions. Some writing of things down needs to happen, and we may need to propose some things to the spec. So please go ahead.
No, I think you're right. Digging any further would probably stretch the meeting too long. I'll think about what it was I was going to try to say. Propose it for the next time around.
So the information that's in the chat, where's that going to be available? Is that going to be on Slack?
Yes, and what I'll do is I'll put it into the description of the video that we're in right now, and then I will also that'll also be included in the email with the link to this video. So all of that will be available in several different ways, and I'll put it on Slack too.
On Slack, there's several channels, FPGA general and all that. Does it need to have an M17 specific channel or not, or is it just going to be, the discussions in general? In general?
That's kind of a good question. Gosh, there are ways to have cross project channels, but I'm not sure how that works with Discord. There's an awful lot of channels on Discord, and there's at least one where the protocol stuff happens. So I don't know. Let me think about it and see what I can do. If it ends up being a much lengthier project, then then I guess the answer would be yes.
I'm not advocating for it. I'm just asking the question. I'm just saying.
Oh, sure. Yeah, that's a good one. Yeah, we'll keep it in general for now. And then, if we annoy everybody, then we'll put it into a channel, so my approach is if a subject seems like to organically emerge into a subject that needs its own space, then it gets it. So I don't know yet, but I think we'll stick to general for now. All right. Any last comments from Jay or Douglas?
Nope, I'm just going to keep plugging away.
Yeah, thank you. It's a good and very appreciated work. All right.
Did we decide on M17 over IP versus IP over M17?
Yeah, we talked about both. the,
But we didn't conclude anything.
I think we've concluded that we're in good shape and that both exist and that, you know, what we have is M17 native, we're just handling M17 on the uplink, that M17 already has a protocol field for IPv4, that if you really wanted to put IPv4 in M17, you could, and that the appendix in the specification already defines a way to do M17 already over IP, and that we don't need to do anything drastic at all, that it's pretty much worked out.
Yeah, and
We
that's all.
definitely-
Sorry, it's all
Sorry.
assuming that the M17 directly inside of GSE is fine. It doesn't need to be wrapped in IP before it goes into GSE.
Correct. We don't need to do that. And both Howie and Anshul both came down on that side back in 2021. And I think what Ron is saying, Ron Economist is saying, is that when he says what needs to be defined is how to do IP over M17. But I think that just that having the protocol identifier and then shipping IPv4 within M17, with of course the limitations that Paul brought up, that's not our job. That's a M17 job, and I think that's set. No, we don't have to do any work there. There isn't anything to add, so we're in good shape.
It would be useful to have an example in the appendix possibly of how to do these different encapsulations over M17. So
I
that-
actually, yeah, I agree. I actually wrote that down, that, you know, wouldn't it be cool to have, you know, a hello world for all of this? And when I saw Winlink, I know some people that would be excited about that. And, you know, so I'm looking at 6LoWPAN and familiar with that as well. There's some really neat things that could be done. So I agree with you.
Yeah, a question occurred to me, which I have not yet researched, which is the packet mode supported at all in the M17 mod and M17 DMod programs that already exist? And if it is, then it would be easy enough to do some demos with that. If it's not, then that's where it needs to go first, probably, is to add implementation of all the modes into those examples.
fairly certain that the mod and demod are only doing codec stuff.
Yeah, let's refer to that.
All
It-
right.
There's a lot of stuff in those programs, so it's not something you can just read and say, oh, I know what to do next. At least not for me.
Right. Okay, well, we will do this again. Thank you. I will edit and share the recording, and I will include all of the text that we talked about, the links, and notes and the actions that I wrote down. And then please correct me where I messed up something or got it wrong or left it out.
Oh, one thing, Leonard, can you provide a reference to where to start to read about CCSDS?
Yeah, sure. I'll send a couple of links. I'll put it in Slack under general. Is that okay?
Yes, thank you.
If you want, I could just send it to you, Paul.
Oh no, general's good. I think.
In public
Okay.
is better than in private in general.
Okay. They have a very full and rich set of documents that goes into everything in pretty good detail. I've worked in it quite a bit in past life, so
Yeah, it's high quality stuff. It's
I think
well,
so too.
it's-
And
it
it's
is-
flexible. There's something for everybody.
yeah, well worth all of our time to dig into that too.
Yeah, and from an open source perspective, because I mean, I think the Europeans have adopted a lot of it. I mean, that's where they originate. You know, and from an open source perspective, I think you get a lot of bang for your buck if you're doing that. And there's also a fairly rich resource pool of people that know how to deal with it. So anyways, okay. I'll give some links and some of my favorite docs and stuff like that.
Thank you.
But okay.
Awesome. All right. I will see y'all soon. Thank you so much.
Thanks.
Have a wonderful day.